Hey, hello and welcome to the show. It's the final one of 2024. Thanks for joining me. I'm John Park. This is JP's Product Pick of the Week. And we are keeping an eye on our chat. So if you're wondering who I'm talking to, well, it's you. But if you want to type along, come by and say hi. You can jump into the YouTube chat, or you can check out our Discord, which is at adafruit.it/discord. Look for that live broadcast chat channel right there. And hello to C. Grover and Jim Hendrickson and Starman. Thank you for stopping in there. Hey, over on YouTube, Connor McCarter. Thank you for stopping in. And before I forget, I should say Happy New Year's Eve to you all. That's coming right on up. This is it. This is December 31st. We are ready. Are we ready? I think we're ready. Hi, Toddbot. Toddbot stopped in and said, ooh, yes, I have fancy stage light set up. These are these cafe patio lights that we sell, and actually that's going to be part of today's demonstration. So if you're curious about these things, I can talk to you a little bit about them and show you how I'm using them. So before I get any further, I'll let you know where you can go to check out this week's product pick. It's right there. It is at product ID 6066, so you can go to adafruit.it/6066. That's the shortened URL for that. Or look at this QR code right here. Use that. That'll work. Hello, Charlene. Hello thanks for stopping by. Happy New Year's, folks. Nice to see you over there. Is it Charlene or Charlene? My apologies, or maybe another pronunciation. But hello. Speaking of blinky LED art, nice to see you. Hi, over in our YouTube, Jeff Hunt and KC. Hello, hello. Early Happy New Year's to you too. So that right there, that's the URL I want to go to. And as I like to do, I'm going to have Lady Ada jump back just a little bit in time. This is a pretty new one here. So we'll jump back just a little bit in time to have her talk about this week's product pick. So take it away, Lady Ada.
Pixel shifter.
Yes, so we have this NeoPixel shifter. I designed this because I was working with NeoPixels that were being very finicky, really wanted 5-volt signal, not 3-volt signal. And so I was like, if only I had a little board that was like little tiny and easy to use. So this board is easy to use because you don't need any tools. Other than a screwdriver, you don't need to solder anything. You can have two 3.3-volt data line inputs, and you'll get two 5-volt outputs, and you'll also get one inverted line, which is useful for chips like the TM1814. I learned that that it needs a NeoPixel signal, but it's like the opposite polarity, and so one of the pin out, it will give you that pin out, so you can easily drive those without having to like do custom NeoPixel code. There's also one NeoPixel on board, so if you want a test signal to make sure that you're getting proper NeoPixel, it'll light up to let you know that. And it's just like, I don't know, easy to use. Just use terminal blocks, open it up, screw some wires in. And so if you're having really flaky behavior from your NeoPixels or NeoPixel compatibles or AP102s, I recommend getting the shifter. Definitely, I've seen a lot of people, especially if you have a 6-volt power or a little bit higher, and the strips are sensitive, they really want 5 volts, but you're using an RP2040 or a Raspberry Pi, this will solve it for you, and it's only a couple bucks.
That's right. Yes, this is it. This is the product pick of the week this week. It is the Adafruit Pixel Shifter. That right there will allow you to use NeoPixels and other RGB pixels with your 3-volt logic microcontrollers, and some of those strips, they don't love that. They don't love that 3-volt logic coming through. This will do the level shifting you need. It'll give you a boosted 5-volt source. It also gives you an inverted copy of the 5-volt data side of it, so you can use some of the more esoteric strips out there. And it is plug and play. You don't need to solder. In fact, you can't. You're just going to use the little screw terminals there to send in voltage, ground, data, and possibly clock if you're using something like dot stars. And then on the way out, you'll get the 5-volt version of the logic. You have a common ground, and then you'll probably feed it voltage from another supply. I'll show you a 12-volt supply that I'm using, in fact, for this one here. And again, you can get a clock out of that that's also at 5-volt logic levels, and you can get an inverted copy of the 5-volt logic level data from that. So that's what it does, and normally you could set this up on a breadboard with a bunch of parts and some wiring, but this makes it really plug and play, nice and easy to use to get your pixels working with your microcontroller or single board computer. So as Lady Ada mentioned, there's a bunch of different chipsets that are going to benefit from this: ESP32, RP2040, STM32, some SAMD, as well as your Raspberry Pi and other single board computers that are operating on a 3-volt logic level. What else should I say about this? We've got a let me show you the down shooter. This is going to be kind of blinding right there right now, but you can see it has a I'm gonna zoom way in here. Hold on. Let's get close. It's going to be hard to see. Oh, why is that upside down? Oh, that part's not upside down. So I'm going to remove power from it. There we can see it right now. But what you were being blinded by there is it has a little debugging NeoPixel on there. Oh, can you see that? Yeah. So as you're sending NeoPixel info to this with the intention of it being sent along at 5-volt, we also have an onboard NeoPixel that will light up to tell you what's going on and help for debugging. Also on the back side of it is a jumper that you can cut if you don't want that onboard NeoPixel. If that's spoiling your effect of your lighting setup, you can go ahead and slice that, and that'll fix that. What else do we have to say about it? Yeah, onboard is a 5-volt boost charge pump, so that's what takes the incoming 3-volt off of your microcontroller and has that 5-volt reference, and then the level shifter can take both the clock and the data in and level shift those from 3 to 5, as well as the inverter is built onto there. Let's take a look. In fact, before I demo it, let's take a look at the page right here. You can see on the right here, when I refresh this, we have dropped that price down to $2.25. So it's pretty dang cheap, especially right now. It's always just $4.50. Pretty good for what you're getting in the ease of use. But right now it's $2.25. You can get up to 10 of those if you have big plans. No resellers allowed. And if you scroll down here, you will see there's a link right here for the primary guide. This gives you the salient information. There's a nice close-up of the chip that you can see there. You can see there on the back we have a nice little silk screen that tells you everything you need to know, and there's the little NeoPixel jumper you can cut. We have a little pinout diagram here, so this shows you all the inputs and outputs I just mentioned. And then we have a CircuitPython setup, an example, and an Arduino setup, an example. To be honest, you're just going to follow any of your normal RGB LED, addressable LED code. It's just coming out of your pin that you select, you're going through this and then off to whatever your strip is. So there's no unique code for this. You're just sending NeoPixel or similar data out, dot star data out, your data and clock. If you take a look at the little downloads section here at the end of the guide, you'll see we have a schematic and fab print. If you take a closer look at the schematic here, you can see what's going on. We have this AP3602 that is boosting your 3 volts that are coming in up to the 5 volts, which is then used by this one here, the 74LV C2G34. That's the level shifter. I think it might be a quad level shifter. We're using just 2. Could be wrong on that. And then we also have the inverter. So that's, you can see data 3 and clock 3 volt coming in, data 5 and clock 5 volt coming out, and then a copy of that data 5 volt heads over to the inverter, so you get that inverted data 5. And that's it. And then it also mentions our little NeoPixel and jumper you can cut there. The lights that I'm using for this demo are these cafe patio lights. So these want a 5 volt data level. They use a 12 volt power source, so we're already wiring it up a little differently than just running it off of a microcontroller. And the ones that I'm using are RGB. we use a regular data line on those. However, if you check out the other version of these lights that we have, these are the RGBW ones, and they use the TM1814 chip on them, which does require the inverted data. So you're going to need something like this pixel shifter here to use those cafe lights, and it mentions that in the description there. So just a caveat there, you won't be able to drive these with a regular microcontroller. You'll have to go through an inverter of some kind. All right, so let's get to a demo here. I'll just go, I'm just going to go to this view here and plug them in. Let me bring up the board there so you can see I have, excuse me, I have a QT Py. I'm abusing the STEMMA QT port there. This is not I2C. I'm just using that to have a convenient no solder way to get a power, ground, and a data line. So I happen to using I think the SCL or the SDA one. Let's see, I'm just checking my code. Which one did I pick in the end? Pixels are on SDA1. So I think that's the blue. Is it the blue line? Yeah, that's the blue line coming off this little STEMMA QT port. That runs into the 3-volt data in. There's my 3-volt power in. There's my ground. And then coming out of this, I just have ground, which is on this little gray wire here running into this set of patio lights. And then the 5-volt shifted data is on this yellow wire here. So that's what's running that. I'll go ahead and plug in the QT Py. So I should mention there's a 12-volt plug going to those lights. That's where the power is coming from with a common ground. So you'll see that's now going to blink to show me that it is active and running. And then rerun it there. Good demo. I just broke it. Oh no. Let's restart you there. Oh, I know why. I told it not to run. Okay, I told it to pass. I just wanted to have the solid lights to begin with. Okay, now in my main loop, I'm going to run through the animations. There we go. Resave that. And I'll move this out of the way a little bit. So you can see here I've got some cool chase light patterns running in different colors. You can see it's RGB, running a little, I should say, comet. Chase and then comet. I've also got an RGB comet on there. So anything you want to do with NeoPixels or other RGB addressable LEDs you can do with this, but thanks to this level shifter, we're not having weird glitchy first pixels. We're not having color oddness. It's predictable. It functions as you wish. So that's the benefit of that. I'll show you what the code looks like for this, but it is no different than any NeoPixel code. I just happen to be using our LED animation library, which is an easy way to get some of these cool animations. You can see here I'm setting a number of pixels as 20. Pixel pin here, I'm using this SDA1 coming off the QT Py. This could be anything, any digital pin that's capable of sending the NeoPixel data. And there is my strand being enumerated, so pixels, pixel pin, number of pixels, brightness. And then in this case, these are actually in RBG order, which is a slightly odd order. So I've picked that out right there as a string. There's a little note added to the NeoPixel guide and to this guide to tell you how to use kind of arbitrary pixel orders, pixel color orders. Then I'm setting up a few of these LED animation objects like a solid, a chase in a few different colors, a rainbow chase, a comet, a rainbow comet. And then I'm creating an animation sequence of those. Those run until they complete and then advance to the next one and loop forever. And so you can see here, if I want to just simplify back to what I had originally, the only bit of this that's going to matter is me running this solid animate right here. So if I change the color, let's say to purple, well, I'm going to zoom out. Do I have a zoomed out view? One second. Change the scale and crop. send that to you. There we go. So you can see the full strand now. So if I change the color on this, I'll do, let's say, purple, hit save, and we're just changing the whole set of lights there. You will notice the NeoPixel that's built onto the board is going to disagree with that. And by the way, someone asked in the comments if I had some diffusion plastic here, and I usually do, but I'm not seeing it, so I think we'll just be blinded a bit. Sorry about that. You'll notice the onboard NeoPixel is in the usual, I think it's GBR or GRB color order, so it is going to disagree with this. There's not a way to tell this to be a different strand. It's just, I think, always going to mimic what the first pixel on your strand is doing. So just keep that in mind if you see a difference between the onboard debugging NeoPixel and the strand. It's because you have a different color order between the two. That's just a physical difference between how the diodes are ordered in there. All right, let's see. Let's see if we've got any questions, and I'll jump back out to a full view right there. We can run this again. Let's see, in the chat. And yeah, Mike P says, I had no idea there were lights like that. So cool, yeah, so these are, I can't really move them because I've hung them up on here, but they are little fake plastic bulbs. There's no vacuum or anything going on there. Little soft plastic bulbs that are just made to, I don't think you can get them off if they're glued into there. Made to look like a bulb, and then there's a neat little plastic lensing light pipe. There are 3 RGB LEDs in there, so it's essentially 3 NeoPixels per. And these run off of 12 volts just to deal with the long run of them and how many pixels we have. It's actually triple the numbers. This is actually 60 pixels we're lighting up on this one of RGB, so about, I don't know, 60 milliamps per times 60 if you're at full white. So having the 12 volts helps us with this many pixels, and also doing long runs because you can screw in another one. There's a little pigtail cable there you can plug in. All right, I think that's it. Did we cover it all? Let me know if you have any other questions, and we will begin to wrap this up. Yeah, that's all I got for you. Okay, so thank you again so much for stopping by on the 31st of December, 2024, last day of the year. Hope you have a fun time tonight if you're participating in any New Year's Eve festivities, and stay safe. And I'll see you next year. So for our final product pick of the week this year, it is the Adafruit Pixel Shifter. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you next time. Bye-bye.